Welcome back. This is Professor Jim Caffey, and this is Chapter 5 on Radiation and Spectra. We can look at our sun in ultraviolet light. James Clerk Maxwell unified the rules governing electricity and magnetism into one theory. We can make waves, such as these in a pool of water. We can describe waves as how high or how low they go, the crest or the trough or valley, and how big they are by wavelength, how long they are. We can talk about light in what is known as the inverse square law. And what this says is that if you double the distance to an object, you take that number, square it, so we get something, we double it, 1/4, 2 squared is 1/4, pick the inverse of that. If you triple the distance, it's 1/9, 9 squares versus 1. So that light will only be 1/9 as bright when the object is 3 times further away. The Earth's atmosphere blocks a lot of radiation, and so here on the ground we get radio waves. We can get visible light through an optical window through the atmosphere, but infrared, X-ray, gamma rays, these do not come through our atmosphere. And so they require space-borne telescopes. This is a map in the X-ray sky. We can describe radiation laws. This is known as Wien's law. Wien's law. And this says that if an object is red, it's going to have a cool temperature and be faint. If it is blue or white, it's going to be a very hot temperature and be a lot brighter. A prism can break up white light into a rainbow, and we call that rainbow a continuous spectrum. In a continuous spectrum, white light passes through a prism and all colors are dispersed. The visible spectra of the sun shows many areas of dark lines. These dark lines represent what the star is made up of on its surface and in its atmosphere. And so we can see what the sun is made up of by these dark absorption lines. Now within dark lines, we can also have emission lines. So the bright lines are called emission lines. A water droplet can act as a prism to create a rainbow. Niels Bohr and Max Planck described how the atom would behave under certain conditions. In the Bohr model for hydrogen, you have shells outside of the nucleus. And in these shells, you can only have certain energies come in or go out. Depending on the amount of energy used to get in or out will determine what spectral features, those dark and bright lines, we see. In a bright line spectra, you have the emission lines. In a dark line spectra, you have the absorption lines. And it is this that is about 80 to 90% of all astronomy is the continuous spectrum with dark lines or an absorption line spectrum. We can talk about the Doppler effect. Doppler effect is a blue shift towards an observer or a red shift going away from an observer. We see this and we hear this with sirens from the police or an ambulance or a fire truck. And that's it for chapter 5.